Okay, we'll go ahead and get started. Okay, just to get a sense of where we are in this semester, this is week number 7. So week number 9 is usually a good time for the midterm. I know it probably should theoretically fall in week 8, but the first week we don't do a whole lot. So week number 9 usually ends up being a good spot, and we've covered enough at that point that we can actually make a real midterm. Due to the obvious circumstances of coronavirus making everything difficult, I'm deciding to make this a take-home exam. I don't normally do this. I'm going to try it out this semester. It might be a one-time thing. This might be the last time this class ever does a take-home exam. But the way it's going to work is when I enable the exam, you'll have 48 hours. So what I'm thinking is class will be on the 14th. So at the end of class, so nobody's working on the exam during class, right at the end of class, I'll enable it. And then you'll have 48 hours from that point to submit the exam. Okay. Just to give you a rough sense, typically I time the exam at 1 hour and 15 minutes. Obviously, that's very difficult to enforce with a take-home exam. There's just all kinds of logistical issues. So I think it just makes more sense just to open the exam and then everybody in the class has 48 hours. If you finish the exam in 15 minutes, that's great. If it takes you 3 hours, that's just a part of it. But you'll have that time. Now I realize this is the first time I'm trying this for this class. I've done take-home exams before, but for mostly like online classes. I realize a lot of you work and have other obligations. So if this just isn't going to work for you, if you know ahead of time that Wednesdays and Thursdays, and I guess a little bit of Friday, you just aren't going to be able to find, let's say, a 2-hour time period where you can work on the exam, let me know ahead of time. I imagine for most people, like I said, normally in class you get this is an 1 hour and 15 minute class. Normally you just get your 1 hour and 15 minutes to work on the exam. So realistically, I'd say maybe make sure that you've got like 2 to 3 hours that you can do the exam. The testing center is not going to be open, so it's not like you can go to the testing center and do this. So anyway, I'll give you more details next week, but I just wanted you to be able to mark this on your calendars and just know ahead of time that maybe some of you might want to start working on your schedules now to open up some things to make sure that you can actually get a few hours free during that 48-hour period on the 14th. And again, I think I'm going to unlock it at the end of class because I don't want everybody working on the exam and ignoring lecture that day in class. So I'll most like the timer will most likely start at the end of class. And that'll also give me time, I guess, to go through the directions during class and make sure everybody's super clear. Okay, so we'll worry about that next week. I'll give some more details about what how that's going to work. Assignment number 4. I did a quick check. I think everybody got that submitted. I opened up some time on Friday to do like video conferencing help, and I don't think I got anybody from this class. I'm guessing I probably won't do that again. It'll probably just be on a request by request basis. Don't forget, I always do have my office hours. They are asking that you schedule ahead of time because they're trying not to get a bunch of people in the office suite at the same time. But don't forget, I always, if you ever have questions, so if you have any questions that you need answering, office hours are a good time. If you need like actual tutoring, just on the other side of this classroom, we have actual tutors, so you can do that as well. Okay, and then we have a new assignment. Keep track of your dates here. That's going to be due in a week and a half. So not this Friday, but the following Friday. And the reason I'm not making it due on the 14th is because I just know how things are. A lot of people are just going to wait till the last minute for the assignment. Regardless of what the due date is, you'll wait till the last minute. And so I don't want you trying to work on assignment number 5 and the exam at the same time. So let's just get assignment number 5 out of the way and then worry about the exam, okay? I'll explain assignment number 5 in a little bit. So, any questions on any administrative things before we get started? And again, let me know as soon as possible if you just can't make your schedule work for this midterm. Like you can't just find a period of, let's say, 2 to 3 hours where you can sit down and work on this exam in a quiet area. Let me know and we can come up with other arrangements. I don't want to make this like last like a week long because then it just gets too complicated at that point. Okay, so let's get right into some coding today. So just as a quick review, let's go through for loops. Okay, and you're streaming, perfect. So last class we did while loops and for loops. And remember that you can actually technically write code in either. They're interchangeable. But really, while loop is while some condition is true. For is when you have a very specific structure of when you need to set something up while some condition is true, and then you need to do something afterwards. And most often, it's just counting by 1. It's a very, if we just need to count from 0 to 4, for loop is going to be your go-to. Okay, so we say for, let's write the basic structure. And remember, there are these 3 parts. There's the initial setup. Going back to our while loop, remember how we did that? We said there was code that we executed exactly once just to set everything up. That's what's going on here. While some condition is true, let's keep life simple. We'll just say while I is less than 5. Note these semicolons. Okay, in while loops and if statements and the other time we've used these curly braces, we haven't had semicolons in here, and off the top of my head, I think for loops are pretty much the only time that you put semicolons inside of these parentheses like this. But we kind of have to because it's really 3 things going on here at the same time. Not at the same time, but within the parentheses. So our initial setup, this occurs exactly once. This is our check. While this is true, keep on running the code inside of here. And then finally, I is equal to I plus 1. We have to eventually make progress towards some goal. Eventually, we'd like to make this thing false, or else it runs forever. Does anybody remember the name of the type of loop that runs forever? I had a specific name for it. It's a something loop.
Infinite loop.
Infinite loop, perfect. Infinite loops can be useful, but most of the time, that's not what we want. Most of the time, we want to eventually make this thing false, so it doesn't run anymore. And so let's just keep the example kind of, and remember how these work, by the way. This I is equal to I plus 1. It looks at the right-hand side of the equal sign first, calculates a result, and then stores it over here. And we get 0, 1, 2, 3, 4. Quick note, the reason we count from 0 probably isn't going to be super clear just yet. It has to do with once we get into arrays and memory addresses. Just know for now that we generally count from 0. And that's why we say up to but not including 5, because we want to count 5 things, but if we're counting from 0, that means we go 0, 1, 2, 3, 4. What happens the last time through the loop? We'll get, when I is 4, it'll say, okay, at the end, it'll say 4 plus 1 is equal to 5. Store that over here. And then it's going to say, is 5 less than 5? No, that's not true. And if we make it here, we know that the for loop is finished. The reason that this doesn't print every single time is because it's outside of the for loop. Okay, this is often a source of confusion as I get people putting things inside of the for loop that you don't want executing a bunch of times. Make sure that you know that the stuff outside of the for loop isn't going to keep on executing over and over again. The idea is that anything that we want to run multiple times, that goes inside of the for loop. If we want to repeat it, we put it inside of the for loop. But anything outside, we know it's just going to be our normal code execution that we're used to, where it just executes one line at a time and it doesn't repeat itself. Now, one thing you remember from last time, hopefully, is that we don't want to hard code the number 5, because what happens? If we use this number, what's that?
What if you want to change it?
Exactly. And if we're using this in multiple spots for various calculations, like last time I think we did the average of a bunch of numbers, this is very fragile. And in general, we might get it to run correctly once, but code is a living thing. People are going to go back and modify it. And so we want to set this up in a way where when somebody makes modifications, the chances of them introducing some sort of issue are low. So what did we do? We had this thing called a const, which means that it doesn't change. It's like you can always think of it as read-only. Int. And then we said count. Okay, now this can be anything. This is just, I just chose this name because it's very generic. Remember that when it's capital like this, it sort of implies that it's a const. It's not going to change. That's why we previously, I said don't use capital letters in your variable names. This is why. It's because when you see capital letters like this, yeah, it'll run, it'll compile, but other programmers are going to look at your code and they're like, that's kind of confusing. They've got a capital C for Celsius, but it's not a const. That's a little confusing. But and then remember, for most of the course, we've just been declaring our variable and then assigning in a second line. But it turns out that just as a shortcut, we can do all this in one single line. Going forward, we will often do this. But note that the reason I spend so much time treating them as separate things is because I want you to understand that they are separate things. It's just a shortcut that we can do both at the same time. And then don't forget we have to actually replace that here. Now, some of you from other programming classes, you may realize that, or you may see that this can be shortened. So let's talk about that a little bit. Any questions on this? One thing I would recommend, this is about the point in the course when people really start to get lost. Not everybody, but let me just go through some common things I've seen in the past. I kind of have to speak in generalities because you have to remember I see a lot of students each semester, and I kind of look at the things in common that each student is doing. Be able to, so you might want to make yourself like a little cheat sheet or summary sheet of some sort of the main things that we've covered in this class, to where you can have a one-page reference. That way, if I write a piece of code that's a little bit unclear, you can go to your summary sheet and reference that. Now, I could give you that summary sheet, but half the learning process is making the summary sheet. So It'd be kind of, and again, you can probably go out there and find them on Google and stuff, but I would highly suggest you make your own because, again, part of the learning process is just making the summary sheet. And cover each thing that we've gone through. What a variable is, the data types. Think of every single thing that we've covered in the course. If statements, 2 if statements versus if, else if. What was the difference? Remember, we did some examples back then. If I want to make a menu-based program, and it doesn't have to necessarily be a single sheet. And you might want to handwrite it. That way you can write little notes and stuff off to the side. I mean, if you want it more readable, I guess you could have a typed version. But I would highly suggest at this point in the course, start summarizing everything you've learned up to this point in the course. Pretend that you're going into an exam, and I said, okay, get everything into a couple of sheets, and you can use these couple of sheets on on the exam. Because what I've noticed is that the people that start to do poorly at this point in the semester, they'll ask me, what does some piece of code do? And then they won't know how to go back themselves and look it up. They'll just be confused. We've covered it in class before, maybe even a few times, but it just isn't in their memory anymore, and they don't have a way to quickly refer to it. Okay, so that's one thing. Another is be very methodical about how you go about things. I've just seen far too many people in this class just add code until it works. And that might work for some assignments, is that you just keep on adding stuff and then eventually it works and you got it to work, you don't know how. The problem is that the next assignment isn't going to get any easier. It's just that process is going to be even more difficult. So as you go through, remember the code runs top to bottom, left to right, except for in some special cases like this equal sign. And again, you might want to put stuff like that on your summary sheet. But don't just add random code. You're not going to get to the end result. You have to think through the process and go through previous examples. I really do my best to try to not give you something just completely outside of what we've covered. Usually it's some combination of 2 or 3 things that we've covered previously in the class. I try to keep it to 2. Okay? So, and get good at pattern recognition. If you look at your code and it looks absolutely nothing like we've ever covered in our class examples, then you're probably on the wrong path. Okay, so these are just some hints. I know everybody's different. Everyone has their own method of learning. These are just some differences I've seen of people who make it all the way to the end of the course with a good grade and people who, about this point, right around the midterm, they just never recover because this early stuff is fairly straightforward. It's just once we get to the next part of the course, all this is assumed, and I don't go through and re-explain things a million times. Okay, so just a few hints. I don't want to go on too long about it because we're kind of limited in our class time. So let's do this. So I'm going to comment this out. I'm going to copy and paste it. And I'm going to give you another equivalent version of this. So this is this version right here. Remember, comments 2 slashes. This code's not going to actually execute. Let's just run it to confirm. It still compiles. Everything's good. Perfect. What we're doing here, this idea of taking the old value of a variable and adding some number to it and then storing it over here, this is such a common operation that there's actually a shortcut for this. Okay, and this shortcut is plus equals. And what we can, these two are the equivalent, is what we're saying is take the old value of I, add 1 to it, and then store it over here. So this is the longhand version. The reason, hopefully, that you see I really try to show you the longhand version for as long as possible is because it really gives you a sense of what's going on. Is that I'm taking the old value of I, adding 1 to it, and then storing it over here. That's exactly what's going on here. Is I'm saying take the old value of I, add 1 to it, and then store it. By the way, this works with other things. We can do minus equals, we can do multiply equals, but most of the time it's just a simple plus equals. But now this idea of counting exactly by 1 is so common that we actually have one more shortcut. And it's just I++. And that's going to be that's going to be the version that we use in this course. But I want you to be able to recognize all 3. All 3 have their time and place to use them. In this case, in the for loop, because we're counting by one and it's such a common operation just to count by one, we actually have a shortcut for that. It's just plus plus. By the way, where have you seen this plus plus before? Maybe on day one of the class. What's the language that we're writing in? C++. So there was a language in the 1970s created called C, and so programmers in general aren't very clever about naming. So there was a language called B back when they were working on another system, and then they created a language called C, which was supposed to be an improvement. And then C is kind of a smaller version of the same language that we're using. Then in the 80s, a guy also at Bell Labs created a language called C with classes. So it's supposed to be an object-oriented language. And eventually, I think he just wanted to keep the tradition going. So what did he call the language? C++. And the idea is supposed to be that it's one better than C. And then Microsoft in the 90s, so then there was another guy who created a language called D, which never, I mean, it's kind of popular, not super popular. But Microsoft wanted to keep the tradition going in the 90s, and they created a language called C#. So are there any musicians in here? So what is C# in relation to C? Half step up. And so that was their little joke, is that they, so. But hopefully you see the reason now that we actually have the language is called C++ is because of this thing right here. Okay, so any questions about this? This is going to be the form that we most commonly use. So let's take this and let's do something a little bit more interesting. And we could copy and paste, but let's get into the habit of writing these for loops from scratch because they're just so often used that we want to, just like I make you do this hello world all the time, sometimes it's good just to rewrite it. Especially without a bunch of comments, rewrite it in the form that we're most often going to use. Okay, so don't type this just yet. And let's make sure we haven't dropped any. Perfect, okay. We've learned the basic mathematical operators. So addition, subtraction, multiplication, division, but there's actually a fifth, and it's this special symbol right here. So when you're learning something new, I could tell you what it does, but let's go through and let's see if we can just, using our pattern recognition skills, see exactly what it does, okay? And I'm going to change this a bunch of times, so don't worry about typing it. I'll tell you when you can start typing again. So I'm going to do, and by the way, so this is pronounced mod. The full word would be, I guess, modulo or modulus. I usually just say mod. So this would be 9 mod 3. And this returns 0. 10 mod 3 is 1. So 9 mod 3 is 0. 10 mod 3. What if I did 12 mod 3? Okay, that's interesting. What about 21 mod 3? 22 mod 3? 23? 24 mod 3? We get back down to 0. And I will give you a hint. I'm guessing the reason that they chose this percentage sign is because it has a slash in it, so it is related to division. So does anybody have any ideas of what this modulus operator does? Yeah.
It shows the remainder.
Perfect, exactly. It gives you the remainder. So whatever operation I do, 9 divided by 3 has no remainder. But if I do 10 divided by 3, that gives me a remainder of 1. If I do 11 divided by 3, so we don't really care about how many times it divides it, we just care about the remainder. And so if we go to 12, we can see here that there's no remainder. What's cool about this is, okay, this is a very simple way to be able to tell even and odd numbers. So we could say a very simple definition for an even number is if I divide it by 2, if there's no remainder, i.e. if the remainder is 0, then I know it's an even number. So here, 12 divided by 2, that should have no remainder, so this is obviously an even number. 25, that's going to have a remainder of 1, so it's going to have a remainder, so we know that's an odd number. So let's go ahead and write a program that makes use of that. Okay, so go ahead and type this. We're going to start with our const int count, and we'll do 25 numbers here. Okay, so again, this is you're typing this example because now that you understand what modulus does, it's the remainder. We can go ahead and use this in an actual example. And we write the basic structure for a for loop. We're going to say for int I is equal to 0, I is less than count, I plus plus. And just to make sure that we've written our for loop correctly, let's go ahead and do cout I. It should give us 0 to 24, so 25 things, but we're counting 0 to 24. Perfect. Hopefully, by the way, some of you might have been confused initially. Why didn't we do less than or equal to? It's because we're saying we want to count 25 times. And if we start off at 0 and we did less than or equal to, we'd actually be counting 26. And so that's why we do this, is that we say, okay, starting at 0, count up to, but not including the number of things that we want to count. Okay. Just as a little side note. I remember when I first learned for loops, I was always very confused why we did that, and it sort of made sense once I started into arrays and other things like that. Okay, so we know this much works. And I want to be able to tell if a number is even. So the way we do that is obviously inside of an if statement. And I want to know if the number that we're currently on is even. So we already learned from before that I can do some number mod 2, but now because I'm dealing with I, so we've got a bunch of numbers here. I'm going to say I mod 2. But that's not enough, because I mod 2, that's going to give us the remainder. We have to actually check to see if that remainder is equal to 0. We can get into whether 0 is even or not, but by this definition it is, because if I divide 0 divided by 2, that's going to be 0 with no remainder. So don't change your code, but I want you to understand the difference, because what happens a lot of times is there's this idea of Remember that everything in these parentheses, it has to evaluate to either true or false. And this is very clear. I say if I divide by 2 and the remainder is 0, if that is true, then the number is even. This becomes a little bit less clear because what's going to happen is this is going to return a bunch of zeros and ones, and then it'll say, okay, but I can sort of interpret a 0 and 1 as a true and false. And so you end up with this weird situation where you feel like you've written the algorithm correctly, but it's saying that 3 is even, which is not true. Why is it doing that? I don't want to get into it, but it'll try to interpret zeros and ones. So just be very careful that we actually say, okay, after dividing by 2 and I get some result, is that result equal to 0? Remember, we have the 2 equal signs, which means equality. 1 equal sign means assignment, like we did up here. 2 equal sign, I'm checking to see, is this thing right here equal to this? And if it is, run the code in here. Now, because it's just going to toggle between 0 and 1, we can very easily say, okay, well, otherwise, we'll just assume that I is odd. And you can see here, okay, 18 is even, 19 odd, 20 even, perfect. So just to do a quick review, we started off with just a simple for loop like we've done a couple times before in this class. And if you need to go back and review the structure, remember the lectures are recorded. And the idea is that this is going to cycle through 25 times, and each time through, I is going to be a different number. We're just incrementally counting by 1, so it's just going to count by 1. Very simple. And then we introduced this new thing, this modulus operator. It's not very often used, but it can be very convenient when you need it. And what we're doing here is whatever number we have, remember it gives us the remainder. So if we divide by a number, so if we divide by 2 and there is no remainder, well, we know that's an even number just by how we're defining it. And then because it's just going to go back and forth between 0 and 1, we can assume otherwise it's odd. Now, say for example, we wanted to count the even and odd numbers rather than just printing them. So let's do this. Let's comment out this is even, is odd thing. A very common task is to keep some sort of area where you accumulate values. And let's say if I wanted to count the number of even and odd, first of all, what data type? Well, it makes sense as an integer because I'm not going to have 1.5 even numbers, right? I'm just going to have a whole even number. So let's say int even. And we're going to start off with 0 even numbers. Same thing with odd. We haven't seen any odd numbers either. So we're saying outside of the for loop, I've declared these two variables, even and odd. What would happen if we put it inside the for loop? It would get reset every time through the for loop. This is one thing I've noticed a lot of people have, not a huge number, but enough have difficulty with, that when you put code outside of the for loop, that's code you just want to run one single time. And then usually you do things a bunch of times inside the for loop, get some sort of result or some sort of side effect, and then when you're done with the for loop, do whatever. In this case, we're going to print the number of even and odds. So here we know we're on even numbers. Well, what we could do is say even is equal to the old value plus 1. But what did we learn today? What's a short shorter version when we're just counting by one at a time. Exactly. We can actually, because we're just, every time we see an even number, we could say, okay, increment this by 1. We can just do even plus plus. And then the same thing for odd numbers. We can say odd plus plus. So where do we know the final total of even and odd numbers? Which line number? Looking at my screen right here, at what point would we know how many total even and odd numbers we've seen so far? Inside the for loop or outside the for loop? Outside, because the whole purpose of the inside of the for loop is going through that process of actually counting them. So in this case, we saw 13 even numbers and 12 odd numbers. Okay, so any questions on this so far? Now, one of the things that we always want to do is, I don't want to say necessarily break the code, but I want to go through and introduce mistakes. So don't change your code. This is the version I want you to have for your notes. Let's do a little thought process here. What would happen if I added the code here instead, inside of the for loop? What would happen? What would the effect be?
Reset with the loop.
So we only set it, so this was our initial condition. So we can kind of think of this as the reset. But you're on the right track, is that there's going to something's going to happen over and over in the loop. So let's go ahead and run it. So do you see what happened now? Is that each time through the loop, it printed out however many even and odd it had seen up to that point. Does that make sense? And that's not what we really wanted. What we wanted was the total at the very end. And that's why we put it outside of the for loop. Issues of what to put inside of the for loop and outside of the for loop, that's I've noticed that it's not super common, but it's common enough I want to bring that up, is that make sure that you know that whatever you put in the for loop is going to run a bunch of times. And if your goal is just to print the final total, go through that thought process, that logic, that, okay, well, if I want to print it just once, the final total, that needs to be outside of the for loop. Okay, and let's just run this to make sure it actually works. Okay, so any questions at all on this? Okay, let's do another thing using the mod operator. By the way, example number 2 and 3, this is going to lead right into your assignment, so make sure that you understand these really well. So I don't want to get into it too much, but because it's kind of a longer, copy this. So there's a kids game called Fizzbuzz. And the basic idea is that you sit in a circle, and if you divide by 3 with no remainder, you say fizz. If you divide by 5 with no remainder, you say buzz. And if it's both, so you see 13, 14, if it's both, we say Fizzbuzz. And I'm guessing it's just to teach kids some basic division, a little bit of getting used to numbers and so forth. Now, this is kind of an older thing now. Nobody really does this anymore, but I remember years ago there was an article. It's probably referenced here. Yeah. So it's going all the way back to 2007. And there's a hiring manager who also happened to be a programmer, kind of famous in tech circles, not incredibly famous, but anyway. He came up with a very simple program that can be written in pretty much any programming language. And the basic idea was just to find out how many people could actually code and how many people were just good with the knowing the terminology and that sort of stuff. He wanted a very, very simple example that could be written in a few lines of code to see if people could actually think for themselves. And eventually he wrote this article, which made it so that you can't really use it anymore because it's a very famous thing. But if you're interested in the history of it, it's kind of an interesting article because he found that actually a lot of people applying for programming positions couldn't actually program. I don't know how true that is, but that was his experience, and that's where he came up with the program. Anyway, so it's just one of these things where it has a lot of history. It's kind of famous amongst programmers. And so we're going to do a variant of that. So you understand the basic game when it's, when you're trying to teach kids math. Let's do the programming version. So it should already be clear that we can use the mod operator. We just learned this. That fizz, I need to say, if the number mod 3 has no remainder, then it's a fizz. If the number mod 5 has no remainder, it's a buzz. And then when it's both, it's a Fizzbuzz. Okay. And you should also note that, how sometimes I like to, through the first round, write a program incorrectly. I want to go ahead and do that. So let's do this. This will be one of those examples where, because I'm going to change code so much, we'll get to a point where, so don't code it just yet, and then I'll get to a point where it's the version I want you to have for your notes, and then you can copy it. Okay, so for right now, just watch what we're going to do. So, and you can even, if you want, set up the basic structure. So we'll just do like they did before, say const int count is equal to, we'll say 25 again. Now this version is going to be a little bit different because I think technically the game starts counting at 1. So rather than int I is equal to 0, we'll say int I is equal to 1. I is less than count, I plus plus. Let's just make sure that works. So if you want, you can set up the basic skeleton or the structure for the program. Okay, so now I'm going to start solving the problem, so don't type this part, but knowing what we know from our even and odd, well, we're going to say, okay, if I mod 3 is 0, so if we divide the number by 3, so like for example 9, that's going to be a fizz. So we'll just do cout fizz, and then else if I mod 5, that's going to be a buzz. And then if it's both 3 and 5, that was the last rule, remember? 15, both 3 and 5. Now, I realize some of you might realize that you can just divide by 15. I don't want to get into that right now. Just so we get more practice and it's a little bit clearer, we'll say I mod 3 is equal to 0 and I mod 5 is equal to 0. Then, so if both are true, then it is, oops, I already messed it up, sorry. So this is fizz. This one's just going to be buzz. And then fizz, buzz. So we've basically implemented the logic just like the example in Wikipedia. So we divide by 3 and there's no remainder, we say fizz. If we divide by 5 with no remainder, it's going to be buzz. And if we divide by 3 and 5 with no remainders, it's Fizzbuzz. So let's go. And then one thing I like to do is just throw a final else in there just to know which number we're on. So I can just do a cout I. And we start going through here and it runs. Okay, so the first number, good. 1, 2, fizz. 5 is buzz. Let's check 9, that's good, fizz. 10 is buzz. We get to 12, that's perfect. But 15 just said fizz. What was it supposed to say? Fizz buzz. Does anybody have any idea what happened? And this is actually sort of related to some of the things that we've done earlier in this class. Yeah. Yeah, exactly. So what happened, remember the nature of if, else if, is that the first thing that matches is what gets executed. And because we're in a situation where 15 is divisible by 3, it matched this, and it said, oh, because if it's an if, else if, that it's because it's of that structure, I don't even need to check the rest of these. Does that make sense to everybody? So remember that the ordering of this is important, and the structure of if, else, ifs are important as well. And just like you said, what we can do to fix that is that we can actually put this thing as the very first thing to check. We can say, okay, first check the most specific case that is divisible by 3 and 5. Make that the first thing. And then these can become... And I think that I moved that around correctly. Let me just do a double check here. So if it's 3 and 5, fizz buzz. If it's just 3, fizz, 5. And then let's go through here. So 1, 2, fizz, buzz. We get to 9, fizz, buzz. 12 is correct. Now when we get to 15, what happened was because it was both divisible by 3 and 5, it said fizz, buzz. And then it didn't even bother checking the rest of these because remember just the nature of if, else, ifs. And if you're unclear about that, I'll go back to that old lecture where we went through and I actually showed you the difference between the two, okay? I think it was the car rental example. If you, I don't remember what date it was on, but I think that was the example I really showed that. Okay, so this is the version I want you to have for your notes. Go ahead and type that up. I'll give you a minute. Give it a little bit more space so it's a little bit clearer to read. And I'm just going to shrink this one on the font size just so more fits on the screen. Can everyone still see that? Okay. So this example leads into your assignment, and your assignment is essentially to take parts of example 2 and parts of example 3, and the idea is that rather than doing a cout of these fizzbuzzes, I want you to give me the number of fizzbuzz and fizzbuzzes. Okay? Is everyone done copying? Okay, so let me flip over here. Now, it's a little bit more wordy than that, but that's the basic idea. So we've already done this. So at the end of the program, you see out to display how many times each fizz, buzz, and fizzbuzz was encountered. Very similar to what we did here with the even and odd numbers. Start from 1 and go up to 100. And it has to be calculated using the method from class. If you're trying to do all kinds of other stuff that has little to do with these examples, you're completely going the wrong path. So I'll just let you know that ahead of time, is that it should be a very trivial modification knowing information from this other example. Okay? Any questions? So you have a week and a half on that. Again, you should only be able to use information from examples 2 and 3 today. That should be more than enough to finish this whole assignment. Okay, so we're going to do some more examples today, but just note these have nothing to do with your assignment. So if you find yourself using other techniques that we learned today on your assignment, you're going in the wrong direction. It literally only needs things from these two. Okay. So let's go ahead and start a new REPL here. Let's just get one more little bit of practice with for loops. Okay, so this one I can make large again. So in this example, what we're going to do is ask the user for a bunch of numbers, and at the end, we want to tell them which of the numbers was the largest number. Okay. So because we're going to ask the user for a bunch of numbers, we already know ahead of time that it's going to be a for loop. So let's go ahead and set up const int count. Let's just say we'll keep life simple 5. Set up the basic for loop. Int I is equal to 0. I is less than count. I plus plus. So in this case, what we're going to do is we're going to ask the user for 5 numbers, and then our goal is to determine of those 5 which are the largest. Now we are going to put one constraint because it'll make the program a little bit easier to write. And that constraint is we're only going to deal with positive numbers, so numbers greater than 0. Okay. Now there is a version that we could write where we deal with negative numbers. I just want to, it's more about getting the practice than it is getting every corner case. So maybe we could do that another time. But for right now, I want to keep life simple and just we'll assume that all the numbers are going to be positive. So how do we ask the user for something? Well, we say, okay, cout, enter number. And we go to cin, but we don't have anywhere to put that. So what do I have to do? Declare a new variable. And we'll just say it's a double number, and let's initialize it to 0. So we're being very generic with the name. We're just saying that they're entering a number. It's going to be of a double type. And we'll do that. Now let's just test that to make sure it actually works. Now again, we're assuming that for whatever reason, we're only going to deal with positive numbers. So the easiest way to do this algorithm is that we just say, okay, if the number that they just gave me is larger than any number I've seen before me. And how do we do that? All we have to do is keep one single variable that says, okay, this is the largest number I've seen up to this point. And if they enter a number that's larger than that, that becomes the new largest number. Otherwise, we just keep on going through the loop. Okay, so we'll say double, we'll call this variable largest. And we're going to initialize it to 0. So this works out because positive numbers. So we're going to say the largest number I've seen so far is 0. Because all the numbers that they're going to give us are positive, it makes life very simple because all we have to, the first time through it works. Otherwise, the algorithm would break if we allowed negative numbers. And so what we do is we do a check here that says, okay, if the number that they just gave me, we just very generically called it number, if that is greater than the largest number I've seen up to this point, let's put a little bit of spacing in here so it's a little bit easier to read. If the number that the user just gave me is larger than anything I've seen up to this point, so the largest number I've seen up to this point, then the new largest number is going to be the number that they gave me. Now, if after cycling through all those, I shouldn't say if, so after cycling through that count number of times, so in this case 5 number of times, we should know the largest number that they gave us. And so we can just do cout largest is. So the first time through it said, is 4 larger than 0? And that was true. So 4 became the largest number. The next time through it said, is 9 larger than 4? Well, that's true. So then 9 became the largest number. Next time through it said, is 2 larger than 9? No. Is 1 larger than 9? No. Is 4 larger than 9? No. And then so it knew, because we weren't taking any other path, we were just keeping track of the largest number, that once we exit this for loop, whatever is contained in this variable largest is the largest number. Nothing terribly interesting about that. It's just kind of a common thing that you have to do. Just wanted a little bit more practice with the for loop. Any questions on that? Again, this is not really directly related to your assignment, just kind of a common thing that you'll have to do. Okay, so let's change things a little bit here. Let's go back to talking about functions. So we have, we might have time for 2 more, but I'm guessing maybe just 1. So even though you don't have an assignment related to functions just yet, I want to make sure everyone is getting a good sense of how they work. So we'll just say one final example with functions. So going back to a function, remember the idea of a function is that we have this modular piece of code that we can reuse. It's all right, happens. We have this modular piece of code that we can reuse. There's many reasons for needing to be able to reuse it or have it modular. You can go back to last lecture. But the basic idea is that we've got this box that takes in inputs, has an output on the other side, and then some code in the middle. Now, sometimes we write that code, sometimes somebody else writes that code. In this case, we're going to be doing the whole thing. We're going to be using the function and actually making the inside mechanics of the function. But always keep that mental model of it takes inputs and then it returns an output. Okay? So let's just do a very simple function that given two numbers, the function will let us know which of those numbers is larger. So we'll say, we've done int so far. Let's do double. So we want to know, we'll say num1. That way we don't use a and b for every single one. So it's saying that I'm going to take in two variables, num1 and num2. And it's going to return a double. And so we'll do this. We'll say double result is equal to 0. And then we'll say if num1 was larger than num2, the result is going to equal to num1. Else, result is equal to num2. We don't have to actually do another test because we know that just by logic that it's going to be num2. So last time we didn't use any if statements, but any code that we've written up to this point, remember main itself is a function. So any code that we've written inside of main, and just as a side note, remember we write this outside of main. We write it right here between the using and the int main. So we can put for loops in here, if statements. We can call other functions. So in this case, what I'm doing is I'm creating a variable called result, and I'm populating it based on which one is larger. And then I'm going to, remember, so this is the special part, is that I use this special keyword called return. And that returns out the other side of the box the actual thing that we're going to return. In this case, it's the value of this variable result. So the logic is fairly simple. The user is going to give us, or whoever's calling the function is going to give us two numbers. If the first number is larger, that's going to be what's returned. Otherwise, the other thing is going to be returned. And then we have to actually return, remember, inputs and outputs. We take in inputs. Here we're returning the output to the other side. Now, if we ran this, nothing's going to happen. And why is that? Up here, we've defined the function, but we have to actually call the function somewhere. I called it larger. So here we're calling the function with the parameters 5 and -2. But again, the function gave us something, but we sort of ignored it. We just let it fall on the ground. We have to actually hold that somewhere. And so let's do this. We'll create a variable called number, and then we'll say number is going to be the result of this function. And then let's change up the numbers just to make sure it actually works correctly. So now 2 should be the larger of the two numbers. Okay, perfect. Now, again, I think I've already mentioned this last week, but we've already seen a function in this class since day one. And what's the name of that function? Main, exactly. Remember, this is the name of our function. This is where we take in the inputs. In this case, we're not taking in any inputs because we're, I'll explain that in a second. And then we're returning an integer. Well, we can see down here, here's our return 0. Here's where we're actually returning something. What is 0? Well, when you're writing scripts and doing other tasks, sometimes we want to tell the operating system whether the program's successfully finished or not. For example, if I'm running the program and it tries to open a file that doesn't exist, or the program just flat out runs out of memory, I may decide to return something besides 0, and the operating system says, okay, I'll do something with that error code. In this case, 0 means that the program successfully finished, so we just return 0. So in this case, this has some context, but normally it's like this, where your return value actually has more meaning. And the reason that we leave our inputs blank is because we're not really taking anything in. When we start the program, we're just starting the program, okay? And main is a very special name. It's called the entry point of the program, is that when the program actually starts running, the operating system looks and says, okay, let me find the main function, and that's where it actually starts running it. Yeah?
So why is it not a void?
You can write it for whatever reason in the standard. I think you're supposed to use, if you actually create it as void, I think it'll still run. Some compilers will complain, but that isn't a valid thing that you can sometimes do. Just out of habit, I always make it int, but I think void will work on certain compilers. And then one last quick thing here is that this actually doesn't always have to be empty. So for those of you who ever worked with command line programs, sometimes you know that you run the program and then you have like some arguments afterwards. You can actually take those arguments in through main. So we're probably not going to get into that in this class, but anyway. So okay, so not much time left. Just as a reminder, just make sure to get this assignment complete. Get started on it right away. It's not actually that difficult. Some of you might be able to just after class just finish it. If you find yourself struggling on it, really refer to examples 2 and 3. And then if you need help, email, but include your code. Okay, so for the most part, when you include the code, you can just you know how you can save in REPL and give me a link. Sometimes what happens is if you try to include the code file, the email system thinks that it's a virus. So a lot of times it's just easier to send me the link to your REPL. So okay, so that's pretty much it. Make sure if you're not going to be able to make it, I shouldn't say make it. If finding time during that period on the 14th for the exam, if finding a few hours to do the exam on your own time, if that's going to be difficult, make sure to email me. Next week we'll go into the details of the exam. Contact me if anything